Example 3, evaluating a difference quotient. If f of x equals 2x squared minus 5x plus 1 and h is not equal to 0, we're going to evaluate f of a plus h minus f of a over h. The expression f of a plus h minus f of a over h is called a difference quotient, and it occurs frequently in calculus. As we will see in Chapter 2, it represents the average rate of change of f of x between x equals a and x equals a plus h. So how are we going to solve this? First, let's begin. Okay, so the first thing we need to do is we need to find f of a plus h. So we're going to go ahead and write this as a plus h. And then what we're going to do is we're going to plug that in to the values of x into that function. So it's going to be 2 times a plus h squared minus 5 times a plus h plus 1. Now I haven't put them in there because I want to make sure I'm using the colors here. So we have a plus h squared and then a plus h. So let's go ahead and evaluate this. So this becomes 2 times, well, this is a perfect square trinomial, so it's going to be a squared plus 2ah plus h squared, and that's minus 5 times a plus h plus 1. And then we're going to distribute the value of the 2, and then we're going to distribute the value of the minus 5. So we get 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1. And so from here we need to determine, are there any terms that we can combine? We don't have any. So we know that f of a plus h is equal to what we just solved. Now let's find part 2. Well, what we want to do next is we want to find f of a. So that means we're going to replace all the values of x into that function with a. So now this becomes 2a squared minus 5a plus 1. And so now what we're going to do is we're going to substitute what we found in this example, or in this part, and that part into our difference quotient. So for part 3, recall with our difference quotient we have f of a plus h minus f of a, and we're dividing that by h. So what does that mean? That means we're going to replace now f of a plus h to be 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1, and then we're subtracting what we got for f of a. So that means we're going to have to use a parenthesis or a bracket, and that is 2a squared minus 5a plus 1, and then we're dividing this entire thing by h. So now what we need to do is we need to distribute this minus sign. So we end up with 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1 minus 2a squared. Since we're distributing that minus sign, this becomes plus 5a, and this becomes minus 1 all over h. Now the next step is to combine any like terms or simplify. Well, we can simplify the 2a squared and the minus 2a squared because that's going to give you 0. We can simplify the minus 5a and the plus 5a since that's going to give you 0. And the plus 1 and a minus 1 is also going to give you 0. So what is remaining? What's remaining is, and we'll write this in descending order, so we have 2h squared plus 4ah minus 5h divided by h. Now we're not done yet because in the numerator we have a like term in all three terms, so we can factor out a common factor, which is h. We factor out the h, we have 2h plus 4a minus 5, and then we're dividing that by h. And so what we can do next is we can simplify the h, and then our final result is going to be 2h plus 4a minus 5. So this is going to be our result. Now again, this being our result, what this goes back to again as the definition states is that it represents the average rate of change of x between x is equal to a and x is equal to a plus h.